Hi, today going to discuss about most requested, I would say, um, how to interface C or C++ code for our IP core using MATLAB or Mathematica. So it's quite easy. Uh, First of all, let me give a little bit intro about this math software. Usually, MATLAB is suited for engineers or financial engineering or control engineering who wants to better make use of mathematical models or any invented mathematical equations, so to incorporate in their products or a prototype and so forth. And this Mathematica or MATLAB, usually they are used for rapid prototyping of any mathematical models. So as I mentioned, this is MATLAB is more close towards application engineering, whereas Mathematica is, I would say, best suited for scientists who wants to use this for symbolic programming. Symbolic programming is similar to whatever we write equations in a paper. You can do the same thing in Mathematica. It's quite easy and very powerful. And Mathematica is suited for to understand the underlying concept of an equation. Uh, I would say the best example is if you want to understand how nature works in a mathematical way, you can use Mathematica for the same. Usually, these math softwares are interpreters. In other words, they sit on top of a compiler. So these interpreters are usually very slow, but they are very programmer friendly. The similar thing, you could say, you could look at Java, Python, Scala, or any other programming language. They are going to sit on a basic compiler, C++ or C or C++ or Fortran. So, so whenever we write a code, so those codes are converted into intermediate code, and then this intermediate code is taken from the layer of this native compiler C or C++ or Fortran, and then they'll generate assembly code and execute in machine, any machine architecture. So that's the usual concept so far. Um, but Java, Python, or Scala, or any interpreters, they are very programmer friendly. In other words, very easy to use, quick to execute any application, rapid prototyping of applications. However, this is a picking trend. So most people using these languages for rapid uh, any applications you could think of. Uh, but for hardware, C or C++ or Fortran is the one which understands efficiently, executes the code efficiently. So this is more suited for, I would say, a system architecture or any hardware developers. So MATLAB or Mathematica codes are usually the scripts or that comes in .m file or NB file notebook in case of Mathematica. So to generate MATLAB here, you need a math coder. So the math coder is an application provided by MATLAB. So you put that your script MATLAB code in a math coder. It will generate C or C++ code, and then once you have the source codes, then you can compile in a Vivid compiler, the usual method, and then you execute the code accordingly. So this is the usual process. Now I'm going to show a clip from MATLAB team so that you can understand how it's going to work out.
MATLAB Coder generates readable and portable C code from your MATLAB algorithms. This automated approach speeds up your design workflow and eliminates coding errors introduced by a manual translation process. MATLAB Coder supports most of the MATLAB language and over 1,200 functions from a wide range of toolboxes used for applications ranging from image processing and computer vision to advanced DSP and communications systems development. To illustrate the workflow, I'm going to use a Kalman filter as an example numerical algorithm. The Kalman filter.m file that you see here is slightly modified from the version that ships with MATLAB Coder. In addition, I have a simple test bench which gets the input, runs the Kalman filter, and plots it on the graph. While I have two files, I'm only interested in generating code for the algorithm. Coming back to the algorithm, notice that I'm pre-allocating matrices like A and H. This is one of the tricks that helps generate better code. To start off, make sure you have the %pound codegen pragma at the top of your file. The pragma enables additional code generation checks in the code analyzer, which is a tool built into the MATLAB editor. Taking a look at the code analyzer at the top right corner, we see that it's flagged a couple of things. The first thing is that we need to complete statements with a semicolon. So let's fix that. And over here with the brackets, it's unnecessary, so we can delete it. Thirdly, MATLAB Coder does not currently support try-catch constructs. So let's remove it for now. After fixing these things, the code analyzer is green, so we're good to go. From here, let's go and start the MATLAB Coder app. Here it is under the code generation category. Here's the MATLAB Coder app, and the first thing we're going to do is to tell it which file we want to generate code for. From here, the code generation readiness tool makes an initial assessment and flags things like unsupported functions. If you have no issues, you actually won't see this screen, but in this case, the tool is telling us that import data is not supported for code generation. We wrote this chunk of code for debugging purposes as we were designing the algorithm, and since we don't need to generate code for this diagnostic code, we can comment it out and move to the next step. Now we need to define our input types. When working with C code, we need to explicitly specify the data type and sizes of our inputs. The easiest way to do this is to use a test bench that exercises the function that we want to generate code for. In this case, this is the Kalman filter test bench that I showed you earlier. And if we click on the auto-defined input types, MATLAB Coder will run the test bench and infer the input data types and sizes. It figures out that our input data type is a 2x1 array of type double, so we'll accept that. If you want to, you can also explicitly set the data type and sizes yourself. Moving to the next step, MATLAB Coder is going to check for runtime errors in the generated code. It'll perform things like array bounds checking and dimension checking to look for violations of memory integrity. In this case, everything passes with flying colors, so we can move on. Now we're ready to generate code. For our output, we can generate source code, MEX files, static or dynamic libraries, or an executable. To keep things simple, let's go ahead and generate source code. So we just generated code successfully. I enabled the option to insert the MATLAB code as comments in the generated C code so that it's easier to trace back. We also have a header file here. At this point, there are a couple of things you can do. You can, of course, create a MEX file and bring it back to MATLAB for acceleration purposes. You can tune some of the code generation options related to speed, memory usage, and code appearance, and then regenerate code. You can also do some code verification. Of course, you can simply export the generated code and use it elsewhere. This was a quick overview of generating C code from your MATLAB code. Take a look at our documentation for more examples and other details.
Yeah, so that's about MATLAB. So in case of Mathematica, it's almost similar. So you need to have a third-party package called Math Code C++. So you install this package in your Mathematica, and then once you open Math Notebook NB script, So you just need to type needs math code, and then once you enter that needs math code package, and then you need to set a working directory. So this working directory will tell to the math kernel is that where it's going to generate the source code. And after that you write your Mathematica code. In the Mathematica code, well, maybe you can take whatever the math code you have, copy and paste, and then you generate code. So it's fairly straightforward. So for your convenience, I left a link in the description window below, so please check that. It's very easy to use, and now very fast to it is very fast to it will generate very fast these COC it will generate a C++ code uh, very fast. Yeah, so that's it. If you have any questions, please do get back to me through social media channels, or you can contact us directly. Thank you.